Welcome back, everybody. This is going to be our Algebra 2 exponential functions, lesson number 4, find equations of exponential functions, homework review, part 4. We are now to question number 4. Please make sure to watch parts 1, 2, and 3 for the work on questions 1, 2, and 3 in finding exponential functions. And so with number 4, a population of koi goldfish in a pond was measured over time. In the year 2002, the population was recorded as 380. And in 2006, it was 517. Given that y is the population of fish, and x is the number of years since 2000, do the following. A, represent the information in this problem as 2 coordinate points. Well, first off, if the x value is the number of years since 2000, then instead of using x for 2002, our first coordinate would be just 2. And since y, the population at that time, would be 380. So our first coordinate is going to be 2, 380. In 2006, it was 517. So we're going to use the 6 for the x value for the second coordinate. And then we're going to use the y value of 517, the population there. And so for part A, is just going to be 2, 380 and 6, 517. Part B says determine a linear function in the form y equals mx plus b that passes through 2 points. Well, we'll definitely find the slope, and so the slope here will make this x1, y1, and x2, y2. And so our slope is going to be y2 minus y1, or 517 minus 380, over x2 minus x1, which is 6 minus 2. So we're going to calculate, use a calculator here, just to make sure we get this correct. Yeah. So we have, in this case, 517 minus 380. So our difference is 137. And of course, 6 minus 2 would be 4. Now, it doesn't go in evenly, and if you want to, we can write a decimal. 137 divided by 4, our slope will be 34.25. Now, in this case, we want to find the matching b value. I'm going to probably move this down a little bit, so give ourselves some room here. And so we're going to plug in this case y equals mx plus b. So we'll take the coordinate, and we're going to use I'm going to use this coordinate here, the 2, 380, for my equation. So we'll have 380 is equal to 34.25. That's the m value. My x value will be 2, and we want to solve for b. Well, 34.25 times 2 gives me 68.5. So we're going to get, in this case, 380 equals 68.5 plus b. And subtract 68.5 on both sides. So we will get for our value here, so 380 divided by 68.5 will be 311.5. So b equals 311.5. So our m value is 34.25. Our b value is 311.5. We plug them back into just the values of m and b, and our linear equation is y is equal to 34.25x plus 311.5. And that's our linear function. Okay? It said don't round the linear parameters, meaning leaving m and b as our decimals for now. Well, okay, that's not so bad. We continue with this information, and for part C, determine the exponential function of the form y equals ab dx that passes through these 2 points. round b to nearest hundredth, and round a to nearest tenth. Okay, so here we're going to plug in our values. And if you remember, we had 2 comma 380. So we're using y equals a times b to the x power. Therefore, we'll have 380, that was a y value, is equal to a times b, the x value was 2. We also had our second coordinate of 6 comma 517. So we have 517 is equal to a times b to the 6th power. All right, so our first step is to plug in our values of x and y into our form of y equals a times b dx. Very similar to what we did here, to solve for the b value, after we found the slope, right? And so now what we do, because we don't have a, we're going to divide, and we're going to take our 517 is equal to a times b to the 6th power, and then divide that by 380 is equal to a times b squared. And we'll divide them, and so we see that the a values will divide out. And so we're going to get for our b value would be b to the 4th power is equal to, now 517 divided by 380. Let me just bring up our calculator again. 517 divided by 380. Does that work nicely? I don't know. 517 divided by 380. 1.360526316. Let's see. We should be able to change let's see if we can change our fraction. And yeah, 517 over 380 is the exact value. And we'll use that. No, it's totally okay. All right. But that's b to the 4th power. That's b to the 4th power. Okay. So, all right. So b to the 4th power is 517 over 180. Let's see if I can move this over a little bit here. Give us a little space. All right. So 517 over 180. 380, actually. We're going to raise both sides to the 1/4 power because of the fact that we have b to the 4th, and we're going to raise both sides to the reciprocal of the exponent for the base. So our b value, well, probably end up being this crazy decimal. All right. And so here, let's do this here. We have our answer. We're going to take our answer of 517 over 380 and raise it to, we said, the 1/4 power, 1 divided by 4. And we're going to get this 1.08007413. Okay, now, since we're taking it to the nearest hundredth, it's pretty close to 1.08. So we'll let b be 1.08 here. It doesn't say we shouldn't round off, but we could keep this if we want to. Okay. So it's about 1.08, although we'll save this on the calculator. All right. So it's approximately 1.08. Now to solve for a. Okay, so we're going to plug into, now probably again, I always go for the smaller equation. So we'll plug into here. So if 380 is equal to a times 1.08 squared, again, it's 1.08.000 and so on and so forth. No, but we're going to take this number, we're going to divide both sides by this 1.08 squared. 1.08 squared. And so we get a by itself. So this divides out. Now go back to our calculator. Okay. So our calculator, we're going to take the number of 380 and we're going to divide that by, going to bring some number up here, enter squared. And we're okay with this because of the fact that the law of order operations will make sure we take the exponent first and then divide. And so we take this number, all right, and we're going to hit enter, and we get 325.7842794, which in this case we're going to round the a value here, our a value to 325.8. Okay, so instead to round off to nearest tenth, which in this case is the first decimal, and because the fact 8 is greater than 5, we add 1 to the 7. So we get 325.8. So now we get, so A is equal to, so A is approximately 325.8. Our B value is approximately 1.08. And so our function here, exponential function, will be y is equal to 325.8 times 1.08 to the x power. So our b value is nearest 100th and a to nearest 10th, which is 1 decimal place. So this is going to be the answer for exponential function. All right, so D, which model predicts a larger population of fish in the year 2000? Okay, so in this case, we're going to now plug in 0 for x. For the linear function, when y is equal to 34.25x, this is times 0. Now, why at 0 for x? Well, since they said that x represents the number of years since 2000, well, at the year 2000, x is 0. So plus 311.5. Our y value is 311.5. For the exponential function, we have y is equal to 325.8 times 1.08 to the 0 power. And 1.8 to the 0 power means we get 1. This whole thing goes to 1 here. So 1 times 325.8 means we'll get 325.8. Now, which model predicts a larger population of fish in year 2000? We notice that the exponential function, or the exponential model, predicts a larger population of koi fish in the year 2000, because in this case 325.8 is greater than 311.5. So there's a large population of koi fish. The exponential model, sorry, next I forgot to put the word model here, so let's talk. I said it but didn't type it. Predicts a larger model koi fish, published koi fish in the year 2000 than the linear model. Okay, because in this case again 325.8 is greater than 311.5. I'll make this full screen so you guys see everything here. All right, ladies and gentlemen, hope this has been helpful. And these are types of word problems you should see, expect to see maybe our final coming up later on this semester. So yeah, so in this case, first you got to find the coordinates based upon the words they give us. We found the linear function and the exponential function modeling these two coordinates. And notice how determined that they have the same coordinates, but having a different model gives us two very different results. And so, based upon this, if we use the exponential function, we'll get we'll predict a larger number of fish in 2000. In this case, everything about a model is about predicting in later days. So we have, for other information, we don't have those. So I hope this is helpful, ladies and gentlemen. If you have found it helpful, please give this video a like. Really appreciate it. And if you have not subscribed to the channel yet, please do so and turn on notifications to know when new videos are added to the channel. So, ladies and gentlemen, I hope you hope you enjoyed part 4, and I hope you catch parts 1, 2, and 3 from previously, and our next part 5. Look forward to seeing you, ladies and gentlemen. Take care and be safe.